Hello everyone. So today we're going to be learning about our next conic section, which is hyperbola. This is 8-3 and it's on page number 663. All right. Okay, what does it mean by hyperbola and how does it look like? So let's talk about that. So hyperbola is the one with two parabolas going opposite direction. So let's say if I draw a graph like this with two parabolas going opposite direction like this, that could be an option. Or, first of all, I want you to understand the difference. So if you look at the first hyperbola, so what I see is, I see these parabolas going opposite direction, but both parabolas are on the x-axis. If I look at the second one, these parabolas are on the y-axis. Okay, so what are the vocab terms? Before, for ellipses, we have major and minor axis. Major for the longer one, minor for the shorter one. So that doesn't go with hyperbola. So how does it work? So basically, the axis that has parabola on is called the transversal axis. So in case of the first one, so the x-axis would be the transversal axis. And in case of the second one, since hyperbola is on the y-axis, so this y-axis would be the transversal axis. Okay. Next, so for the first one, if x is the transversal axis, then the other one, the supplementary, the other axis is called conjugate axis. This is called conjugate axis. So same thing applies for the second one. For the second graph, the conjugate axis would be the x-axis. Few more terms. So we have vertices and co-vertices. So vertices, obviously, it's going to be the vertex for those parabolas. So for the first one, my vertices going to be these points. So these points, the points where the parabola starts at, so that's called vertices. So for this one, these two are vertices. And other axis is just going to have co-vertices on that, right? Okay, so for the next part, in order to understand the equation, so what I'm going to do is, on the left-hand side, I'm just going to have all the information about ellipses, and on the right-hand side, we'll talk about hyperbola. It would be easier to actually make that connection if I do this. Try recalling ellipses. You have x plus and then y, and then it was equal to 1, and then each variable has a distance under that, right? So it was a squared and b squared, and sometimes these two switch, right? Depends on the major axis. If the x is major axis, then a goes under x-axis. If y is the major, then a goes under y-axis. So this switching part depends on major axis. That's how ellipses equation go. So for hyperbola, it's pretty much the same thing. Now the reason I told you to switch bottom one, because now it's going to be the top one for hyperbola. So it's easier to understand the pattern. So for hyperbola, it's going to be something like this. Still equal to 1. Okay, this time it's not plus, it's negative, or it's minus in the middle. So it would be a squared and b squared here. But now, and before a and b used to switch, now what's going to happen is a and b is going to stay the same. It's the top expression that would switch. So these x and y is going to switch. But how would you know which one would come first? So here's the thing. If the transversal axis, that depends on transversal axis. If the transversal axis means the axis that has hyperbola on is the x-axis, if it's x-axis, then this would be your equation. So it means x would come first and then y. If the transversal axis is the y-axis, then your equation would have y first. It would be y minus k squared. Remember, a and b would stay the same. So that's going to be the equation if the transversal axis is the y-axis, okay? So whatever comes first, that's going to be your transversal axis. It's no more by the bigger number, so let me write that down. It doesn't go by the bigger number. No more. Nope, it's not. Instead, it goes by whichever axis that has hyperbola on, okay? Now, the next equation you needed to know is the C equation. For ellipses, C equation was a square minus b square. So, original was plus, so it means the C equation would have a negative in there. So same thing works for hyperbola. Since the original equation has minus in there, so the C equation would have plus in there. So that's the difference, okay? So rest is pretty much the same thing. So today, I'm just going to show you graphing part. So how do we graph hyperbola? So how do we graph? So let's start off with first example. I have y squared over 16 x squared over 25 and it's equal to 1. So first thing, okay, I see y comes first. So it means the hyperbola or those parabolas would be on the y-axis. So how do we graph? So let's start off with plotting x and y-axis. Okay, all right, so let's figure out all the details. What's h and k in this equation? Since there's nothing added to that, so pretty much I would say 0, 0 for h and k. Okay, and how about a and b value? Remember the bottom number, the first number is a and second is b. So a would be, you got to take square root. So a number is 4, b number is 5. So since 4 goes under y, so it means on the y-axis, you got to go by 4 units. So let's go by 2's. 2, 4. On this side, -2, -4. So these 2 points going to be vertices of this hyperbola, and hyperbola or parabola is going to start from those 2 points, okay? All right, on the x-axis, you have 5 means. On the x-axis, we got to go 5 units both sides. So still going by 2's. Let me pick a different color. So 2, 4, and 5. -2, -4, and -5. There you go. Now, this is something you need to understand. Now you have to connect these points. So first you got to extend and you have to make a rectangle. How does that work? So for this one here, I'm going to draw a line like this. Same thing down here. And now connect. There you go. So that's how we make this rectangle. So once you're done making this rectangle, you need to connect the diagonal and make sure that diagonal should pass through the center of this hyperbola. Like this. Same thing on the other side. Okay, once you have that, so now just extend these lines. Basically, these lines are the asymptote of this hyperbola. Okay, almost there. Now, since we already know y comes first, so it means the vertices is going to be on the y-axis. So these are the points for vertices. And from those points, you just have to draw two parabolas like this. One's going up, one's going down, and basically, hold on. So those two asymptotes, asymptote, your graph's going to get closer and closer to those two lines, but it's never going to intersect. So that's how you need to draw these parabolas, or total combined, it's hyperbola. Okay, so that was my first example. Now let me show you one more example. This is with h and k in it. All right, so I have x plus 3 over 16 y minus 2 square, this is 4, and it's equal to 1. First of all, what's your h value? Remember, h value is the one that goes with x, and k is the one that goes with y. So h value would be -3, and k value would be +2. Okay, what's your, remember, bottom number is still going to be a and b. A is 4, b is 2. Time to graph and make that box. So let's graph this. First of all, do we know what axis our parabola is going to be on? So since x comes in first, so it means those parabola is going to be on the x-axis. So that's going to be your transversal axis. So the center point is at -3 and +2. That's the center point. So from there, on the x-axis, you gotta go by 4 units. So from this point, go 4 units right. Let me pick a different color. 4 units right and 4 left. On the y, I would go 2 up, 2 down. Once I have all 4 points, the rest is I just have to connect these points, make a rectangle, diagonal. So from this, pass through, it should pass through the center point, and I'm just going to extend it right now. Extend. Same thing on the other side. Connect and extend. Here you go. Lastly, I know x comes first, so it means those two parabolas going to be on the x-axis, and I already know these are the vertices. And don't forget, those vertices always going to be on the box. It's not inside, okay? It's always going to be on the box. So here's, and I would just extend, make parabola. Don't forget, it's going to get closer to these asymptotes, but never touches. So here you go. That's how the hyperbola is going to look like. So basically, that's all for today. If you don't understand any of these steps, then you can go back and replay. If you still have any question, comment and I'll answer that. So thank you guys. Thank you for watching. Bye-bye.